Magandang buhay. Today, our topic is all about finding the sum using the formula S sub n is equals to n over 2 times the 2a sub 1 plus the product of d and the n minus 1. So this is actually, we are still in arithmetic series. Okay, so how do we find the sum using this formula? First, okay, we have here a problem. So find the sum of the first 25 terms of the arithmetic sequence 2, 7, 12, and 17. So to solve, first is we are going to identify what are the information. So from the problem, our number of terms is equals to 25. That is why we have n is equals to 25. The next one is the first term, which is equals to 2. And the other one is the common difference, that is 7 minus 2, which is equals to 5. So using now the formula, all we have to do is substitute all the necessary information. So we have there n, which is 25, a sub 1, which is 2, and d is equals to 5. So substituting n by 25, all the n there, for the a sub 1, which is equals to 2, and our d is equals to 5. So first, we do have there 2 times 2. What is 2 times 2? This is actually equals to 4. And the 25 minus 1 is equals to 24. So now, the equation becomes this one. So we have 4, and 25 minus 1 is equals to 24. Then we get the product of the 24 and 5. So what is 24 times 5? And that is 120. So we do have there 120. And this 120 to be added by 4. So 124. So since it would be much complicated if we divide 25 by 2, so we can divide 124 by 2. So 124 divided by 2 is 62. So get the product of 25 and 62. The answer will be 1550. So therefore, if we are going to add this sequence 2, 7, 12, 17 up to the 25th terms, their sum is 1550. Okay, let's proceed to another example. We are going to get the sum of the first 32 terms in the given sequence 103, 197, and 94. Okay, so first is what are the information? Okay, so our n is 32 because we are going to get the first 32 terms. Whereas our first term is 103, while the d here is negative 3. That is 100 minus 103 is equals to negative 3. So that is the value for our d. So using now the formula, all we need to do is substitute all the given information. So we do have the 32 for the n and 103 for the a sub 1, and the d is negative 3. So next thing here is that here, since we can divide 32 by 2, so we will divide this one. So 32 divided by 2 is 16, while 2 times 103 is equals to 206. And the 32 minus 1 is equals to 31. So thus, the expression now will become 16. So this is 2 times 100 is 206. And the 32 minus 1 is 31. So what is 31 times negative 3? So 31 times negative 3 is negative 93. So 16, 206 plus the negative 93. So adding 206 by the negative 93. So this is actually 206 minus 93. So 206 minus 93 is equals to 113. And the product of 113 and 16 is equals to 1808. So therefore, we can say that if we are going to add the first 32 terms from the sequence 103, 197, 94, their sum is 108. Okay. So what about if we are going to find the number of terms? So this time our end is unknown, but the sum is given. So let's have here this example. In the arithmetic series 3, 7, 11, 15, the given sum is 595. What is the n? Okay, so first let us gather all the information. We have the sum, which is 595, the first term, which is 3, while our d there is 4 because this 7 minus 3, which is equals to 4. Okay, now using the formula, that is the s of n is equals to n over 2 times the 2a sub 1 plus the product of our n minus 1 and d. So again, substitute all the given info. So our s sub n is 595. Our a sub 1 is 3, while the d is 4. So 2 times 3 is equals to 6. And then the 4 times the n minus 1 is 4n minus 4. And then next here is we are going to combine the terms, which is the 6 and the negative 4. So 6 minus 4 is equals to 2. So this will become 4n plus 2. Okay. So in this expression here, the 4n plus 2 can be divided by 2. Here, diba? We can divide 4n plus 2 by 2. So if we divide 4n by 2, that becomes 2n, and dividing 2 by 2 is 1. So therefore, the expression here will be 2n plus 1. So we have 595 is equals to n times the 2n plus 1. So since we divide 4n plus 2, so our denominator now is cancelled. So then distribute the n to the 2n plus 1. So we do have 2n squared plus n. So next here, we move 595 onto the right side, or that is the use of additive inverse. So we are going to equate this one by 0 so that we can solve for the value of n. So in this case here, we are going to get the factor of 2n squared plus n minus 595. So the factor of this given is actually 2n plus 35 and the n minus 17. Okay, so we do have two possible value for n. The n, which is 2n plus 35 equated by 0. So 2n is equals to negative 35. So take note, if we're going to divide this by 2, the result will be negative. our n must not be negative because it is a number of terms. So, therefore, this expression here cannot be used. What about the n minus 17? For the n minus 17, using the additive inverse or simply transferring negative 17 to the other side, that becomes positive 17. So our n is positive 17. So n is positive. So therefore, we are sure that this is correct because the value of n would always be a positive integer. Okay. So our n in the expression is equals to 17. So that means there are 17 terms if we are going to add 3, 7, in which the result is 595. Okay, another example. We have here 5 plus 11 plus 17 plus 23, in which their sum is 456. What is the value of n? Okay, so the information, the sum which is 456, the first term which is 5, and their common difference is 6. So using the formula, substitute the value for the s sub n, a sub 1, and the d. So we have 4, 5, 6 for the s sub n, and for the a sub 1, which is 5, and the d is equals to 6. So what's next here is we are going to multiply the 2 and 5, which is 10. And then the n minus 1 times 6 is 6n minus 6. So this is now the expression. So you will have 10 and negative 6. So this is similar terms. So thus we can combine them. So 10 minus 6 is equals to 4. So these expressions here would be 6n plus 4. So that is n over 2, so 6n plus 4. The 6n plus 4 can be divided by 2, so we will divide this by 2. So this will become 3n plus 2. So we can cancel now the 2. So this would be equal to 456 is equals to n times the 3n plus 2. Then we are going to distribute n to the 3n plus 2 or multiply n to the 3n plus 2. So this will become 3n squared plus 2n. And then using the additive inverse or simply moving 456 to the other side to equate this by 0 so that we can solve for the value of n. So now the expression will be 3n squared plus 2n minus 456. So from this expression here, we are going to factor it out. So if we are going to factor it out, you have 3n plus 38 times the n minus 12. Okay, so next here, so we do have two possible values for n. The first n, which is 3n plus 38 is equal to 0, wherein our n here is actually negative. So if we can divide this one by 3, the result is negative. Therefore, this cannot be used because n should be a positive integer. Whereas in the n minus 12, using the additive inverse or moving the negative 12 to the other side, that becomes positive. So our n is 12, and this is correct. So in our problem, the number of terms is 12. So there are 12 terms if we are going to add 5, 11, 17, and 23, in which their sum is 456. So thank you for listening. Have a good day. Bye.